October 3rd, 2025. NASA's Perseverance rover on Mars snapped images of 3 Atlas. Not the sharpest pics, but something. An astrophotographer named Simeon Schmaus stacked 20 of those rover shots, and there it was. A faint smudge of light right where the interstellar visitor ought to be. Folks are buzzing about it, picking it apart, arguing over what it means. But here's the weird part. That very same day, NASA furloughed 15,000 employees. The Mars Reconnaissance Orbiter's high-rise camera, packing 30 times the resolution of Perseverance's gear, was lined up just right for the shot of a lifetime. ESA's Mars Express and ExoMars were tuned in too. Where are those images? And it gets weirder. Remote viewers picked up on technology inside this thing way back in August. A thumb drive-sized gadget planted on purpose in an ancient comet, beaming out signals. They laid this out months before the telescopes caught those chemical anomalies. This is a 2-part video. First half dives into 3i Atlas and all the fresh details. Second half rounds up the week's space news. Timestamps in the description if you want to skip ahead. Before we get into it, if this hooks you, smash that like button and subscribe to keep up. Drop a comment, where you're tuning in from, what time it is there, and what you reckon this object really is. Natural comet or something more? Want to help our community grow? Share this on X, Facebook, Reddit, or your messenger. Thanks for always having our back. Chapter 1, The Cylinder in the Martian Sky. Let me show you something that popped up on Twitter 48 hours ago that flipped everything. A user called UFO Mania shared an image with a caption that rocked the online astronomy crowd. The newest and closest of 3 Atlas, as it swings by, isn't a comet. It's perfectly cylindrical. The post showed what looked like an elongated object, grabbed during the Mars flyby, and within hours it racked up thousands of shares. Now, before you write this off as another online hoax, get why this stands out. This wasn't some fuzzy snap from a backyard scope. The coordinates lined up, the timing lined up, and most crucially, the quiet from official sources lined up. Because here's what's going unspoken. On October 3rd, when Thurston Atlas made its closest pass to Mars at 29 million kilometers, we should have been drowning in images. The high-resolution imaging experiment camera aboard NASA's Mars Reconnaissance Orbiter was positioned perfectly. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter had their instruments locked on the spot. Multiple spacecraft, multiple views, the sharpest look ever at an interstellar object. And we got zilch. Well, not zilch. We got radio silence. But into that void came voices that demanded a listen. An account called 3i Atlas Anomaly started dropping a technical teardown way deeper than your average conspiracy rant. 10 specific points, each backed by real observations. Carbon dioxide-rich coma, spotted by JWST. Water and hydroxyl emissions picked up by SWIFT. Polarimetric quirks showing negative 2.77% polarization at phase angle 7 degrees, a combo never seen in asteroids or comets. Chew on that for a sec. This wasn't loose talk. These were naming real instruments, real data, real science papers. Then came the cosmologist, a Twitter user named Moneypenny, who calls herself a plasma phenomena expert, an ex-BBC journalist, dropped something that gave even doubters pause. She said a top cosmologist named Stefan Burns thinks the object is intelligent, wrapped in dusty plasma, and showing consciousness that's already chatting with us and other planets. Consciousness communicating. Now, you might peg this as fringe stuff, and maybe it is. But here's the hook. This wasn't buried in some obscure forum. This was out in the open, with Moneypenny's creds front and center, her investigative journalism chops on full show, and she tossed in one more bit that chilled anyone tuned in. We can't eyeball it anymore, it's too close to the sun. So it'll be December before we get another look. December. 3 months of waiting. 3 months with the object tucked behind the sun, totally blocked from every scope on Earth. And in those 3 months, if the path shifts, we won't clue in till it pops back out. Then there was Jon Stewart, not the comedian, but a UFO investigator and journalist who posted something that felt like a heads up from another time. My source has gone dark. NASA is shutting down, and even Congress is in recess. If Threeless activates, ancient texts warn the sky will burn with knowing light, and the world will forget its reflection. They called it prophecy. The agencies call it protocol. I call it imminent. Ancient texts, Vatican files, the harbinger. These hashtags were trending alongside technical astronomical discussions. What do you do with that? How do you separate signal from noise when the noise might be the signal? Because here is the uncomfortable truth. In the last 48 hours, as these posts went viral, not a single official image from the Mars flyby has been released. Not from NASA, not from ESA, not from the Chinese Tianwen 1 mission, or the UAE's Hope Orbiter, all of which we're watching. The only visual evidence we have comes from an astrophotographer named Simeon Schmaus, who stacked 20 images from the Perseverance rover's mast cams camera and found what he described as a faint smudge of light in the constellation Corona Borealis, close to the location where the comet was expected. A faint smudge. That is what we got from humanity's closest look at an interstellar visitor from spacecraft that can resolve features smaller than a car on the Martian surface. We got a faint smudge. Unless, of course, they saw something else entirely and chose not to show us. The 3 Atlas anomaly account continued posting updates that grew increasingly specific. Unexpected brightening. The object is brightening faster than models predicted, suggesting more volatile or efficient outgassing mechanisms than expected for its distance. Spacecraft to observe during solar conjunction. As the object slips behind the sun, ground observations cut off. ESA is repurposing Mars orbiters to monitor it near the October 3rd Mars flyby at approximately 30 million kilometers. Every update was technically accurate. Every detail could be verified against published scientific observations. And yet the conclusion they were building toward was unmistakable. This was not behaving like a comet. And then came the detail that nobody could explain away: the shape. Multiple amateur astronomers, working independently, reported the same thing. When they processed their images, enhanced the contrast, removed the background stars, what remained was not the fuzzy, irregular blob you would expect from a comet with an active coma. It was elongated, smooth, almost geometric, perfectly cylindrical, as UFO Mania had said. Now, skeptics would point out that elongation can be an artifact of motion, of image processing, of the way light scatters through a coma. And they would be right. It can be. But it can also be real. We know this because Oumuamua, the first interstellar visitor, was also elongated. Pancake-shaped, some said, cigar-shaped, others argued, but definitely not round. Definitely not what we expected. So when 3i Atlas shows similar characteristics, when multiple independent observers report the same geometric quality, when the official channels remain silent, what are we supposed to think? The answer, according to NASA's carefully worded statements, is that 3 Atlas poses no threat to Earth. Its trajectory keeps it safely hundreds of millions of kilometers away from our planet. It will make its closest approach to the Sun on October 30th, then continue on its journey out of the solar system, never to return. All of which is true. All of which sidesteps the question everyone is actually asking. What is it? And why, on the day we should have gotten our best look at it, did 15,000 NASA employees get sent home? Chapter 2. The Remote Viewer's Revelation. What I'm about to tell you happened in August of 2025, 2 months before the Mars flyby, before the shutdown, before any of the viral posts that captured public attention. And it happened under conditions that make it impossible to dismiss as wishful thinking or confirmation bias. Her name is Bertie Jorski, And if you know anything about remote viewing, you know that name. Former vice president of the Farsight Institute, nearly 30 years of professional remote viewing experience, a master's degree in digital forensics. Not exactly the profile of someone chasing internet fame with wild claims. In August, a friend gave her a set of coordinates, just numbers. No context, no photographs, no news articles. This is how legitimate remote viewing works. The target remains completely blind. The viewer has no idea what they are looking at until after the session is complete. Birdie sat down, entered her protocol, and began to describe what she was perceiving. The first thing she reported was movement through space. Something traveling, something old, very old. She described it as a natural object, icy, rocky, exactly what you would expect if someone asked you to remote view a comet. And for a while, that is all it was. But then she noticed something unusual. There was something that was not completely natural, she said later, in a podcast discussing her findings. There was something strange. The way she described it, it felt like discovering a fingerprint on something that should be pristine, a signature where there should be only by randomness. She kept going deeper into the session, and that's when she perceived it. Something small about the size of a thumb drive. Something that had been deliberately placed inside this object, not on the surface, inside. Someone had bored into this rock, she reported. Bored into this icy rock deliberately and placed something encoded with all kinds of information. It's kind of like an archive, a message in a bottle. But it's not just a message, it's technology of some sort. Now, pause and think about what she's describing. Not alien beings, not a massive spacecraft, a thumb drive-sized piece of technology, ancient beyond measure, hidden inside a comet that's been traveling through the galaxy for billions of years. She went further. This thing is so old. And even though the object itself is like billions of years old, the thing that was placed inside of it is also very old. Did some species there on the other side of the galaxy send up a little robot to bore into it and stick their little message and technology, knowing that this thing was going to keep traveling? It's a question that sounds like science fiction until you remember that we have done exactly this. The Voyager probes carry golden records, time capsules designed to survive for billions of years, in the hope that someone someday might find them. The idea of using natural objects as vessels for messages is not alien to us at all. We just haven't thought about it in reverse. The friend who gave Birdie the coordinates waited until after the session to reveal what she had been viewing. Oumuamua, the interstellar object that wouldn't even make headlines until weeks later. She had been viewing something that most of the world didn't yet know existed. But Birdie wasn't finished. She did 2 more sessions going deeper, trying to understand what she was perceiving. And in those follow-up sessions, she discovered something that changed the entire picture. It's also broadcasting. She reported these messages come out in pulses. Broadcasting present tense. Not was broadcasting billions of years ago, is broadcasting now. When the podcast host mentioned that astronomer Avi Loeb had recently published calculations showing Oumuamua arrived from the same region of the sky as the famous WOW signal from 1977. Birdie didn't hesitate. That's super interesting. She said it's very possible that that's the WOW signal. Now you might be wondering how much weight to give to remote viewing testimony. It's not a conventional scientific method. It can't be easily replicated or verified. Skeptics dismiss it entirely. Believers swear by it. And the truth, as always, probably lies somewhere in the complicated middle. But here's what makes Birdie's account worth considering. She wasn't alone. Multiple remote viewing groups, working independently targeted Oumuamua in the months following its discovery. And while the specifics varied, certain themes emerged again and again. Technology, deliberate placement, broadcasting, the involvement of non-human intelligence. One group reported perceiving humanoid forms associated with the object. Another described what they called graffiti, markings, signatures. Someone had signed it. Several viewers reported the sensation of the object being masked, deliberately avoiding detection as if it didn't want to be fully seen. One particularly detailed report mentioned special access, extraction points, a timetable. These weren't vague, mystical impressions. They were specific technical details that sounded more like intelligence briefing than psychic session. And then, there were the more disturbing elements. References to crop circles, advanced spherical craft, hybrid warfare, invisible war. The phrase brain scanning technologies appeared in multiple independent sessions. The suggestion that whatever this was, it had the capability to influence minds, to incite mass hysteria or hallucination. Now, does any of this prove Oumuamua is anything other than a comet? Of course not. Remote viewing, even at its most rigorous, remains in the realm of anomalous cognition, not hard science. These aren't measurements. They're not photographs. They're subjective impressions filtered through human consciousness. But they are also remarkably consistent across multiple independent viewers who had no contact with each other. And they align in eerie ways with the physical anomalies that telescopes were beginning to detect. Consider what Birdie described: a small technological device, billions of years old, placed deliberately inside a comet. If that were true, what would we expect to see? We would expect the object to look like a comet from a distance. Ice, dust, outgassing, all the normal signatures. But up close, we might notice things that don't quite fit. Unusual chemical compositions, unexpected materials, behaviors that seem almost designed rather than random. We would expect it to be massive, far more massive, bigger than its visible size suggests, because there would be something dense at its core, something that does not sublimate, something that remains intact no matter how much ice boils away. And we would expect it perhaps to be transmitting. Not loudly, not obviously, but if you knew where to look, if you had the right instruments pointed in the right direction at the right time, you might detect something. A pulse, a pattern, a signal that should not be there. Birdie Dworsky perceived all of this in August, before most of the scientific data was published, before the anomalies became undeniable, before NASA went silent. She described a message in a bottle traveling through the galaxy. And now, as 3I Atlas hides behind the sun, as official channels refuse to release images from the Mars flyby, as amateur astronomers report cylindrical shapes and scientists detect impossible chemistry, that bottle is getting closer to perihelion, the point of maximum heat, maximum stress, the point where, as Avi put it, confessions are elicited. If there is a thumb drive-sized piece of technology buried in the heart of this comet, October 29th is when it will either reveal itself or remain hidden forever. And the fact that NASA sent 15,000 employees home right before we could get our best look raises a question that remote viewers have been asking since August. What did they see that we are not being shown? Chapter 3. NASA's Deafening Silence. October 3rd, 2025 was supposed to be historic. The day humanity got its closest look at an interstellar visitor. Mars Reconnaissance Orbiter positioned perfectly. High-rise camera ready to capture resolution 30 times better than anything Hubble could achieve. ESA's Mars Express and ExoMars Trace Gas Orbiter standing by with full instrument arrays. Then, at the exact moment when we needed NASA most, 83% of the agency disappeared. 15,000 civil servants furloughed, gone during what should have been the most intensive observation campaign in the history of interstellar astronomy. The official explanation was simple: federal government shutdown, budget impasse. Nothing to do with 3I Atlas. Just unfortunate timing. Unfortunate timing. Those two words doing a lot of work to explain why the world's premier space agency went dark precisely when an object exhibiting 7 statistical impossibilities passed within 29 million kilometers of our Mars spacecraft. Think about the odds of that for a moment. 3 Atlas was discovered in July. The Mars flyby was planned for months. Scientists knew this would be their only chance to capture high-resolution images before the object disappeared behind the sun. NASA knew, ESA knew, every space agency on Earth knew. And in the final week before closest approach, the United States government shut down. NASA's official website stopped updating. Press releases ceased. The army of scientists who should have been analyzing data, processing images, making discoveries, they were sent home. Only essential personnel remained, a skeleton crew maintaining critical operations. But here's what makes it suspicious. Raw image feeds from Perseverance rover kept uploading. The rover did not stop working. The Mars Reconnaissance Orbiter did not stop working. The cameras were active. The data was being collected. It just was not being released to the public. Amateur astronomer Dobsonian Power, a YouTuber with a solar telescope, posted an image on October 3rd with a simple caption, "What on earth is it?" The image showed something dark, angular, embedded within the expected position of 3I Atlas. Within hours, the post had thousands of views, people demanding answers, people pointing out that if a backyard observer could capture this, what were the professional instruments seeing? NASA said nothing. ESA said nothing. The only official confirmation that observations had occurred came from Simeon Schmaus, the astrophotographer who stacked 20 Perseverance images and found that faint smudge. He posted his work on social media, not through official channels, a private citizen doing the work that space agencies would not. Then came the White House press briefing. Stephen Miller, Deputy Chief of Staff for Policy, was discussing the government shutdown when a reporter asked a question that had been circulating online for days. Has the president been briefed about 3I Atlas? The room went quiet. Miller paused, chose his words carefully, and deflected. The briefing moved on, but the question had been asked on camera in an official setting, which meant it could no longer be dismissed as internet conspiracy. The United States government was being asked directly about an interstellar object, and they were choosing not to answer. Meanwhile, Havel was making the rounds on news networks, Newsmax, CBS, podcasts, anyone who would listen. He laid out the anomalies with mathematical precision. The trajectory aligned with the ecliptic plane, 0.2% probability. The timing optimized for PL interstellar encounters, 0.005% probability. The 7 characteristics that made 3I Atlas unlike anything ever observed. And he kept returning to one point. We need the Mars orbiter data. The high-rise images could tell us the diameter of the nucleus. They could resolve structure. They could answer the fundamental question of what we are looking at. But the images were not being released. On a podcast with Brian Keating, Loeb mentioned that Representative Tim Burchett, member of the House Committee on Oversight and Accountability, had appeared with him on Newsmax to discuss the object. A sitting congressman on national television talking about an interstellar visitor and the suspicious silence surrounding it. This was no longer fringe discussion. This was entering mainstream political discourse. And still, NASA said nothing. The European Space Agency released a statement confirming that Mars Express and ExoMars Trace Gas Orbiter had successfully observed 3I Atlas during the flyby window of October 1st through 7th. Instruments including the high-resolution stereo camera, the color and stereo surface imaging system, and multiple spectrometers had collected data. Data that would be analyzed in the coming weeks, they said. Results to be published when ready. But no images, no preliminary findings, no excitement about capturing unprecedented views of an interstellar object at closest range. Just a dry confirmation that observations occurred, followed by silence. China's Tianwen-1 mission said nothing. The UAE's Hope orbiter said nothing. Every spacecraft at Mars had been watching, and every space agency on Earth had gone quiet. You do not need to be a conspiracy theorist to find this strange. You just need to remember what happened with 2I Borisov, the previous interstellar comet. When it passed through in 2019, images flooded out immediately. Scientists were excited. Press releases flew. The astronomical community celebrated. It was treated exactly as you would expect. A rare visitor from beyond our solar system, worthy of intense study and public engagement. 3I Atlas gets silence. The difference, perhaps, is that 2I Borisov behaved exactly like a comet. It had the right chemistry, the right tail, the right outgassing patterns. It was interesting because it came from interstellar space, but it was not anomalous. It did not challenge our understanding. It did not raise uncomfortable questions. 3I Atlas does all of those things. And so, as it disappeared behind the sun on its way to perihelion, as it entered the one place in the solar system where no telescope on Earth can see it, the silence deepened. Amateur astronomers posted their last images. Scientists published their papers, carefully worded, technically precise, avoiding speculation. And 15,000 NASA employees waited to be called back to work, wondering what their colleagues with essential status had seen in those Mars orbiter images that the public was not being shown. Chapter 4. 7 Impossible Things. There is a principle in science called Occam's razor. When you have competing explanations, the simplest one is usually correct. One anomaly can be explained away. 2 might be coincidence. But when you stack 7 statistical impossibilities on top of each other, Occam's razor starts cutting in a different direction. Let me walk you through what makes 3I Atlas unlike anything we have ever tracked through our solar system. Anomaly. 1. The mass problem. When astronomers first calculated the size of 3I Atlas based on its brightness, they got a number that made no sense. If all that light was just reflected sunlight, the object would have to be somewhere between 10 and 20 kilometers across. For context, Oumuamua was barely 100 milers. Borisov was less than 1 kilom. This thing appeared to be orders of magnitude larger. The statistical models that predict how many interstellar objects we should detect are very clear. Small objects are common. Large objects are exceedingly rare. We should have found hundreds, maybe thousands of Oumuamua-sized visitors before stumbling across something the size of 3I Atlas. The probability was calculated at roughly 0.01%, 1 in 10,000. But then came the astrometric data. Over 4,000 measurements from 227 observatories between May and September. When scientists analyzed the object's trajectory and compared it to pure gravitational acceleration, they found something remarkable. Almost no deviation. Despite heavy outgassing, despite losing 150 kilo of material per second, the object barely budged from its expected path. That implies enormous mass. A nucleus so heavy that even constant jetting of gas and dust cannot push it off course. The calculations suggested more than 33 billion tons, a diameter larger than 5 kilometers, making it not just bigger than the previous interstellar visitors, but roughly 1 million times more massive than Oumuamua. 1 million times. Think about that gap. It's like comparing a grain of sand to a boulder. Anomaly 2. Sunward glow. Hubble snagged the sharpest image yet of 3I Atlas on July 21, 2025. Scientists poring over that shot spotted something no one had ever seen before in any comet, solar system body, or interstellar wanderer. The scattered light around the object stretched roughly twice as far toward the sun as it did sideways or away from the sun. Comets have tails that point away from the sun because radiation pressure shoves dust particles outward. This is straight-up basic physics, backed by thousands of observations across centuries. 3I Atlas seemed to be bucking that rule. The stretch wasn't subtle. It was a 10.1 ratio, 10 times longer sunward than across. And this was viewed edge-on, so the real elongation was even wilder once you factored in the observing angle. Avi Loeb and Eric Kito put out a paper with an explanation tied to ice chunks that sublimate at different speeds based on which side of the object they get blasted from. The physics held up, the math added up, but it demanded a super specific setup that no other comet had ever shown. A one-of-a-kind arrangement that just so happened in an interstellar visitor already full of quirks. Anomaly 3. The industrial fingerprint. In late August and early September, the Very Large Telescope in Chile pointed its UVS spectrograph at 3I Atlas and picked up something that left scientists stunned. Nickel atoms in the gas plume. Tons of nickel, ramping up exponentially as the object neared the sun, following a power law of about 9. But here's the kicker. They found almost no iron. In nature, nickel and iron come from the same supernova blasts. They show up in pretty fixed ratios. Every natural comet we've ever checked has nickel and iron in similar amounts. 2I Borisov, the last interstellar comet, had normal nickel to iron ratios. Every solar system comet does too. 3I Atlas was cranking out nickel with no iron. The only spot we see that pattern is in industrial processes. Nickel alloys, stuff that's been purposefully refined and split apart. The scientists behind this data were cautious with their words. They called it baffling. They pointed out that the temperature at the object's distance from the sun was way too low to vaporize the tough minerals holding those metals under ordinary conditions. They floated some chemical explanations that could account for it, but you could sense the doubt hanging in their prose. Anomaly 4. Polarization from another world. When light bounces off particles, it gets polarized. The level and angle of that polarization reveal the size, shape, and makeup of those particles. Comets have telltale polarization patterns. We've measured hundreds. The signatures are well mapped. 3I Atlas flashed a polarization profile that didn't match anything in the books. 2.77% at a phase angle of around 7 degrees, with an inversion angle of just 17 degrees. No asteroid or comet, solar system, or interstellar had ever shown this combo. The nearest fit wasn't comets at all. It was trans-Neptunian objects and a particular centaur named Pholus, icy relics from the solar system's outer edges with compositions and backstories far removed from your average comets. A paper sent to the astrophysical journal Letters wrapped up that 3I Atlas might be a whole new breed of comet, broadening the range of known interstellar objects. Distinct type is scientists speak for, "We got no box for this." Anomaly 5. The ecliptic alignment. The solar system is mostly flat. The planets circle in a plane known as the ecliptic. Random interstellar objects come from all directions, slicing that plane at all sorts of angles. The odds of an interstellar visitor's orbit lining up within 5 degrees of the ecliptic are about 0.2%, 1 in 500. 3I Atlas showed up aligned within 5 degrees. Not just that, but it's cruising retrograde against the grain of planetary orbits. That's the perfect path if you aim to scout multiple planets with the least tweaks. Anomaly 6. The planetary timing. 3I Atlas will zip close by 3 planets on its flyby. Venus at 0.65 astronomical units, Mars at 0.19 AU, Jupiter at 0.36 AU. The chances of a random interstellar visitor timing its arrival for close passes by 3 different planets? Roughly 0.05%, 1 in 20,000. If you were plotting a recon mission to our solar system, this is the route you'd pick. Anomaly 7. The WOW signal coincidence. In 1977, the Big Ear radio telescope caught a signal so bizarre that astronomer Jerry Amon scrawled "Wow" in the margins. It beamed from the constellation Sagittarius, lasted 72 seconds, and hasn't popped up again despite decades of hunts. When scientists backtracked 3I Atlas's trajectory through in the galaxy, accounting for its speed and direction, they calculated where it would have been in 1977. The answer within 9 degrees of the WOW signal origin. The probability of this alignment is roughly 0.6%. 7 anomalies, 7 statistical longshots, and we're being asked to believe they are all coincidences. Chapter 5. October 29th. The Confession. Right now, as you listen to this, 3I Atlas is somewhere we cannot see it, hidden behind the sun, moving toward a point in space where physics becomes brutally honest. Perihelion, the closest approach to our star. For 3I Atlas, that moment arrives on October 29th, 2025, at a distance of roughly 1.4 astronomical units just inside the orbit of Mars, close enough that the Sun stops being a distant light source and becomes an overwhelming presence. Imagine standing in front of an open blast furnace. Now, multiply that heat by a factor you cannot comprehend. That is what perihelion means for an object coming in from the cold darkness of interstellar space. Sunlight pounding the surface with gigawatts of power. Not metaphorical power. Actual measurable watts. The kind that runs cities. Avi Loeb made an observation that stuck with a lot of people. High-stress environments elicit confessions. He was talking about interrogation tactics. But the principle applies to physics, too. When you heat ice, it cannot pretend to be anything other than ice. When you heat rock, it behaves like rock. And when you heat something that is pretending to be a comet, but might be something else entirely, the mask comes off. There are two scenarios for what happens at perihelion, and they could not be more different. Scenario 1, 3I Atlas, is exactly what it appears to be, a comet. An unusually massive, chemically strange, statistically improbable comet, but natural nonetheless. In this scenario, October 29th marks the beginning of spectacular activity. The surface temperature rises. Volatiles that have been dormant for billions of years suddenly find themselves bathed in solar radiation. Carbon dioxide sublimates, water ice turns to vapor, dust particles lift off in enormous plumes. We have seen this happen before. Comets near perihelion become magnificent. They develop tails millions of kilometers long. They brighten dramatically. Sometimes they fragment under the stress, breaking into pieces that eventually disperse. It is violent, chaotic, and utterly beautiful. If 3I Atlas is natural, we should see something similar. A massive outburst of gas and dust. Brightness increasing by factors of 10 or more. The development of a proper tail, not the anomalous sunward glow, but a classic cometary tail streaming behind it as radiation pressure does its work. And if the object is as fragile as some scientists suspect, if that 5-kilometer diameter is mostly loosely bound ice rather than solid rock, perihelion might tear it apart entirely. We could watch in real time as an interstellar visitor disintegrates into fragments, giving us an unprecedented look at the internal structure of a comet from another star system. That would be extraordinary. That would answer questions about comet formation, about the composition of planetary systems beyond our own, about the processes that fling objects into interstellar space. It would be a scientific bonanza, even if it destroys the object we're studying. But then, there is scenario 2. 3I Atlas is not natural. The anomalies are not coincidences. The nickel without iron, the backwards tail, the perfect alignment with the ecliptic, and the wow signal origin. They mean something. In this scenario, perihelion is not about sublimation. It is about activation. Think about what you would do if you were sending a probe to another star system. You would need it to survive the journey. Billions of years in the cold, radiation, impacts, the slow decay of time. Wrapping it in ice makes perfect sense. Ice is common. It is protective. It makes the probe look natural to any civilization that might spot it before it is ready to be noticed. But once that probe reaches the inner solar system, once it approaches the host star, it needs to wake up. It needs power, and there is only one power source available: the star itself. Perihelion in this scenario is not a stress test. It is a charging station. Loeb laid out the possibilities in his papers with mathematical precision. The object could use a solar Oberth maneuver. This is a real technique used by our own spacecraft. You dive close to the sun, use its gravity to accelerate and change your trajectory dramatically with minimal fuel expenditure. It is the most efficient way to alter course in the solar system. The optimal point for this maneuver is at perihelion, and 3I Atlas reaches perihelion while completely obscured from Earth-based observation, hidden behind the sun. If it wanted to change course without being detected, this would be the moment, or it could release something. Mini probes, small craft that detach, and we use the retrograde trajectory to intercept planets, Mars, Earth, Jupiter, all reachable from this position with minimal course corrections. The timing of the planetary alignments makes this almost trivially easy compared to random arrival times. Lowe was careful to note the implications. If 3I Atlas maneuvers toward Earth when it reappears on the other side of the sun, the financial markets may crash. That is not hyperbole. That is a sober assessment of what happens when humanity realizes it is not alone, and the visitors might not be friendly. But we will not know, not yet, because between now and early December, we are blind. Every telescope on Earth, every space-based observatory, they cannot see behind the sun. 3I Atlas is in a communication blackout that would be perfect for a spacecraft that did not want to advertise its next move. The European Space Agency has a contingency plan. Between November 2nd and 25th, the Jupiter Icy Moons Explorer spacecraft, currently in transit to Jupiter, will turn its instruments towards 3I Atlas. JUICE will catch the object just after perihelion, when it should be at peak activity, when whatever is going to happen has already happened. JUICE was not designed to study comets. Its cameras and spectrometers are optimized for icy moons, for detecting subsurface oceans, for analyzing the chemistry of alien water. But those same instruments can look at 3I Atlas, and because JUICE is between Earth and the Sun, it has a viewing angle we do not have from our planet. If the object develops a massive coma and tail, JUICE will see it. If it fragments, JUICE will document the debris field. And if it does something unexpected, if it maneuvers or releases objects or exhibits any behavior inconsistent with a natural comet, JUICE will record that too. The data will not be instant. Space communication takes time, and JUICE is far from home. But by late November, early December, we will have answers. The same time, 3I Atlas reemerges into Earth's view. December 19th is when the object makes its closest approach to our planet. Still 1.8 astronomical units away. Still no threat, but close enough that every major observatory will be watching. Close enough that we will be able to track its trajectory with extreme precision. And that is when we will know if anything changed. If the orbit is exactly as predicted by gravitational models, we can breathe easier. Another interstellar visitor, strange but natural, passing through on its way back to the cosmic dark. But if the numbers are off, if the trajectory shows even slight deviations that cannot be explained by outgassing or solar radiation pressure, then every assumption we have made about our place in the universe will need revision. October 29th, the day 3I Atlas confesses what it really is. Except, we will not hear that confession until December. And by then, it might be too late to do anything but watch what happens next. Chapter 6. The Global Panic. While scientists debated data and NASA maintained its silence, something else was happening. Something that spread faster than any scientific paper could be peer-reviewed. The internet was catching fire. It started in the United States, as these things often do. TikTok videos showing alleged images of 3I Atlas, some real, most fake, all accumulating millions of views. Reddit threads sprawling into thousands of comments, Twitter, or X as it is now called, became a battleground between amateur astronomers posting legitimate observations and influencers chasing engagement with increasingly wild claims. But America was just the beginning. In India, the story mutated into something altogether different. WhatsApp, the primary communication tool for hundreds of millions, became a vector for rumors that traveled faster than fact-checkers could respond. Forwards in Hindi describing an alien ship in disguise. Videos narrated with urgent voices claiming the object was changing course. screenshots of fake news articles with headlines designed to terrify. One particularly viral forward claimed that world governments were already negotiating with whoever or whatever was aboard 3I Atlas. Another suggested military forces were being mobilized in secret. A third showed an edited image purporting to be from NASA, stamped classified, showing a geometric structure where the comet should be. None of it was true. All of it spread anyway. Hindi-language YouTube channels exploded with content. Some were earnest attempts at science communication, explaining what an interstellar object actually was. Others leaned hard into speculation, blending legitimate astronomical facts with ancient astronaut theories and prophecies. The line between education and entertainment blurred until it vanished entirely. Brazil saw similar dynamics play out on Telegram and Facebook. UFO enthusiast communities, already primed to see patterns in the sky, went into overdrive. Groups that had spent years, people who'd been analyzing lights over the Amazon now, had something concrete to analyze. An actual object from interstellar space, exhibiting behaviors that even scientists called puzzling. The conspiracy ecosystem in Brazil is uniquely vibrant. It blends indigenous mythology, Catholic mysticism, and modern UFO lore into something that defies easy categorization. 3 Atlas became everything to everyone. A harbinger of the apocalypse, a vessel of enlightened beings come to save humanity from itself. A weapon, a gift, a test. Facebook groups swelled with new members. Live streams discussing the object ran for hours. Hosts reading scientific papers aloud, then immediately pivoting to speculation that went far beyond anything those papers claimed. The comment sections were digital campfires where thousands gathered to share fears and theories in equal measure. The United Kingdom, with its long history of crop circles and modern UFO investigations, approached 3 Atlas with a mixture of skepticism and intrigue. British tabloids ran headlines that walked a careful line between sensational and plausibly deniable. Massive comet could be alien tech. Scientists say the scientists in question were usually just a Vice quoted out of context. But the headlines did their work. Russia predictably saw the whole thing through a geopolitical lens. State media mentioned the object in passing, always careful to note American uncertainty and confusion. Some suggested Western powers were manufacturing a crisis to justify increased military spending. Others hinted darkly that the U.S. government knew more than it was saying, perhaps even that American black budget programs had made contact. Russian language forums lit up with technical discussions. The level of astronomical knowledge was often impressive, but mixed in with legitimate science were suggestions that 3 Atlas was connected to various secret space programs, recovered alien technology, ancient conspiracies stretching back to the Soviet era. Then came the Michio Kaku incident. A screenshot began circulating showing the theoretical physicist in what appeared to be a television interview. Text overlay claimed he'd stated that 3I Atlas was on its way to conduct a reconnaissance mission, possibly with hostile intent. The caption read, "It might be an alien probe sent to Earth." The image was real. The context was not. Fact-checkers traced the screenshot back to a Nation News interview from February 20th, 2025. Months before 3I Atlas was even discovered, Kaku had been discussing a completely different topic, likely an asteroid impact scenario. Someone had lifted his image, added false text, and released it into the wild. It did not matter that it was fake. The post accumulated over 290,000 views before platforms started flagging it. By then, it had been screenshot and reshared countless times, each iteration becoming harder to trace back to the fabrication. Lord Bebo, the account that posted it, never issued a correction. The damage was done. Thousands of people now believed a respected physicist had confirmed 3I Atlas was hostile alien technology. NASA tried to respond. Their official solar system account posted on September 30th, Comet 3, I Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away from our planet. This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous. The response was immediate and skeptical. If it is just a comet, why the shutdown? If it is not dangerous, why the silence? If it is natural, explain the nickel without iron. NASA did not engage further. The statement stood alone, a single tweet against a tsunami of speculation. Al Jazeera's fact-checking agency, SANAD, published a thorough investigation. They confirmed that 3 Atlas was real, discovered by the Atlas telescope on July 1, 2025. They verified that it posed no threat with the closest approach to Earth remaining about 270 million km. They debunked the Kaku quotes, the military mobilization claims, the secret negotiation rumors. Their fact-check was solid journalism. It probably changed very few minds. Because while Sanad was checking facts, Avi Loeb was addressing the United Nations. Not officially, not in the General Assembly, but in conversations with delegates, in papers circulated among policy advisors, in quiet meetings where the word existential gets used without irony. He presented his Black Swan event scenario, the idea that low probability, high impact events require preparation especially when we think they're unlikely. A black swan is something that seems impossible until it happens, then seems obvious in retrospect. The concept was developed by Nassim Taleb to explain financial crashes, but Loeb applied it to interstellar visitors. We assume they are all natural because we've only seen natural ones. But what happens when the assumption breaks? The Harbinger started trending, not in mainstream feeds, but in specific communities, tracking 3i Atlas obsessively. The term came from ancient texts, from prophecies that describe messengers from the sky, harbingers of change, of judgment, of transformation. Some took it literally. End times, theology mapped surprisingly well onto an interstellar object exhibiting impossible characteristics. Others used it metaphorically, a harbinger of the new space age, of humanity's awakening to a universe more crowded than we imagined. And through it all, through the panic and speculation and wild theories, one voice kept appearing in the discourse. Stefan Burns, the cosmologist Moneypenny had mentioned, claims circulated that he believed 3i Atlas was intelligent, that it exhibited consciousness, that it was already communicating with us and with other planets. No one could find where Burns had actually said this. No published papers, no interviews, just secondhand reports and cryptic social media posts. But the idea stuck because it fit too well with everything else that was happening. The anomalies, the silence, the sense that something was unfolding just beyond our ability to see it clearly. Chapter 7. December's Verdict. Early December 2025. 3i Atlas will emerge from behind the sun like a swimmer, surfacing after a long dive. Astronomers will find it in the constellation Virgo, low on the eastern horizon in the pre-dawn hours. Magnitude 12 or 13, still too faint for amateur telescopes, but well within reach of professional observatories, and everyone will be watching the numbers. Orbital mechanics is one of the most precise sciences we have. Newton's laws, refined by Einstein's relativity, allow us to predict where an object will be years in advance, down to the kilometer. We can account for gravitational perturbations from planets, radiation pressure from sunlight, even the subtle push of outgassing as comets shed material. When 3i Atlas reappears, its position will tell a story. If it is exactly where pure gravitational calculations say it should be, give or take the expected deviation from outgassing, then we can reasonably conclude that nothing unusual happened during its time behind the sun. It passed perihelion, survived the heat, and continued on its predetermined path into the outer solar system and eventually back to interstellar space. But if the position is off, if the trajectory shows changes that cannot be explained by known forces, then every paper written about this object will need an addendum. Every assumption will crack open because objects do not just change course on their own. Something has to push them. The Vera Rubin Observatory will play a crucial role in what happens next. This telescope, which only recently became operational, represents a revolution in how we survey the sky. Previous asteroid surveys found around 20,000 new objects per year. Rubin found 2,140 asteroids in its first 10 hours of operation. 10 hours, 2,000 asteroids. The implications are staggering. When Rubin turns its attention to searching for interstellar objects, the trickle becomes a flood. Scientists estimate we could be detecting dozens of interstellar visitors per year instead of one every few years. And each one will be studied with the lessons learned from 3I Atlas fresh in our minds. We will know what to look for: the chemical signatures, the polarization characteristics, the trajectory alignments. If 3I Atlas is truly anomalous, we will have other objects to compare it against. If it is the first of a new category, Rubin will find its siblings. But December is not just about orbital mechanics and future surveys. It is about questions that have been building since July. What did the Mars orbiters actually see? By December, the government shutdown will be long over. NASA will be back at full staff. The high-resolution images from October 3rd will have been processed, analyzed, and either filed away or prepared for publication. Those images taken when 3I Atlas was just 29 million kilometers from the camera could resolve features on the nucleus if the coma was not too dense. A 5-kilometer wide object at that distance should show structure, not fine detail, but gross morphology. Is it round, elongated, irregular? Are there variations in brightness suggesting different materials on the surface? Does it look like other comet nuclei we have photographed, or is it something else? The fact that these images have not been released raises questions that will not go away just because the calendar turns to December. Scientific data is usually published as quickly as possible. The competition to be first with new findings is fierce. The fact that multiple space agencies observed 3I Atlas at Mars and none have released detailed imagery suggests either massive coordination and silence, which seems unlikely, or that what they saw requires careful consideration before going public. December will force a reckoning on this silence. Either the images emerge and confirm it is just an unusual comet, or the absence of images becomes its own answer. Radio astronomers will also be watching. The WOW signal connection is either coincidence or it is not. If 3I Atlas was the source in 1977, and if it is still capable of transmitting, December provides another opportunity to detect something. Multiple radio telescopes have been quietly monitoring the region where 3I Atlas should be. Not with the fanfare of SETI's usual campaigns, but with steady, patient observation. Any signal, any pulse, any pattern in the radio frequencies that correlates with the object's position would be revolutionary. The hydrogen line at 1420 MHz is the frequency to watch. That is where the WOW signal appeared. That is where any civilization trying to be heard would broadcast, because hydrogen is the most common element in the universe, and its spectral line is a universal constant. If 3I Atlas has something to say, that is where it will say it. December 19th marks the moment of closest approach to Earth. 1.8 astronomical units, roughly 270 million kilometers. For perspective, that is about 1.5 times the distance from Earth to the Sun. Not close by any measure that matters for safety, but close enough that parallax becomes significant. Parallax is the apparent shift in an object's position when viewed from different locations. As Earth orbits the Sun, our viewing angle on 3I Atlas changes slightly. By measuring the shift with extreme precision, we can triangulate the object's exact distance and velocity. Any deviation from the expected values becomes immediately obvious. Observatories across the globe will coordinate observations, northern and southern hemispheres, different longitudes providing round-the-clock coverage. Amateur astronomers will contribute data alongside professionals. It will be one of the most thoroughly documented observations of any solar system object in history. And somewhere in all that data, we will find either confirmation or contradiction. Confirmation that this is, despite everything, a natural object from interstellar space exhibiting rare but explainable characteristics. an ambassador from another planetary system. Strange because it formed under different conditions than our solar system's comets, but ultimately following the same physics or contradiction. Something in the trajectory, the chemistry, the behavior that cannot be reconciled with natural origins. A data point that breaks the model. Evidence that forces us to consider what we have been avoiding considering. By late December, 3I Atlas will be fading again as it recedes from the Sun, moving into the constellation Leo, heading back out toward the orbit of Jupiter, which it will pass in March of 2026. After that, the outer solar system, the heliopause to stellar space. One way or another, December will give us answers. Not all the answers, but enough to know whether we are watching the greatest comet show of our generation or the greatest upheaval in human understanding. Since we realized Earth was not the center of the universe, the telescopes are ready. The equations are prepared. The world is watching. Now we wait for 3I Atlas to emerge from behind the Sun and show us what it really is. Chapter 8. The Scientific Impossibilities. Let me take you deeper into the science that is keeping astronomers awake at night. Not the speculation, not the theories, but the actual measurements that do not make sense no matter how many times you run the numbers. Start with the WOW signal. August 15th, 1977. The Big Ear Radio Telescope at Ohio State University was conducting a routine SETI survey when it detected something that should not exist. A narrowband signal of 1420.4 MHz, exactly where you would expect an artificial transmission. It lasted 72 seconds, the exact duration the telescope's beam would take to sweep across a stationary source as Earth rotated. The signal was strong, 30 times louder than the background noise. On the printout, the intensity values climbed from the normal 1s and 2s up through 5s, 6s, and peaked at U, the highest value the system could print before it ran out of alphanumeric characters. Astronomer Jerry Amon saw those values climbing and wrote one word in the margin. Wow. They searched for it again. For years, decades, the Big Ear telescope pointed at that same patch of sky hundreds of times. Other observatories joined the search. Nothing. The signal never repeated. After a while, it became astronomy's most famous mystery. Evidence of nothing. Proof of nothing, but impossible to forget. Now trace 3I Atlas backward through space. Account for its velocity of 60 km/s. Map its trajectory through the galaxy. In 1977, it would have been roughly 600 astronomical units from Earth, 600 times the distance from Earth to the Sun, 90 billion kilometers away. At that distance, to produce a signal as strong as what Big Ear detected would require a transmitter outputting gigawatts between half a gigawatt and 2 G$ of power. That is not a battery. That is not a generator. That is a nuclear reactor. Sustained output focused into a beam, narrow enough to reach across 90 billion kilometers and still register 30 times above background noise. Could a comet do that? Not with any physics we understand. Comets do not generate gigawatts of power. They do not emit coherent radio signals. They do not broadcast at the exact frequency that happens to be the universal marker for technological civilizations searching for each other. But an object designed to be found, an object that needed to announce itself before it entered the inner solar system, that would broadcast exactly this way. One strong pulse, enough to be unmistakable. Then silence, because you would not want to give away your position until you were ready. Now move to the chemistry of the Very Large Telescope data, showing nickel without iron. In nature, these two elements are bonded together from birth. When a massive star explodes in a supernova, it forges heavy elements in the inferno. Nickel-56 decays into iron-56. They're created in the same nuclear processes, bound in the same minerals, released into space as an inseparable pair. Every meteorite, every asteroid, every comet ever analyzed shows them together. The ratio varies slightly depending on the environment, but they are always both present. 2I Borisov, coming from interstellar space, just like One-Eye Oumuamua showed normal nickel-iron ratios. Solar system comets show normal ratios. There is no natural process at the temperatures. One-Eye Oumuamua experiences that can separate these elements. But refinement can, smelting, chemical processing, industrial production of nickel alloys requires removing iron contaminants. We do it on Earth every day. High-purity nickel for electronics, for specialized alloys, for applications where iron would interfere. The process leaves a signature. Nickel without iron. The scientists who published this data from the VLT tried every natural explanation they could imagine. Maybe unusual chemical pathways in the ice. Maybe exotic minerals formed under conditions we've not seen before. Maybe dust grain physics we do not fully understand. Every hypothesis ran into the same wall. The temperature is too low. The environment is wrong. This should not be happening. And it is not static. The nickel production increases with decreasing distance from the sun exponentially by a power law of roughly 9. That means every time the object gets 10% closer, the nickel output increases by a factor that climbs steeply. This is not random outgassing. This is a process ramping up as solar energy increases, almost like something powering on. Then there is the tail that points the wrong way. The anti-tail that breaks one of the simplest, most reliable rules in planetary science. Solar radiation pressure is not subtle. When photons from the sun hit dust particles, they transfer momentum. It is a tiny push, but relentless. Over time, it overcomes the weak gravity of a comet and drives dust particles away from the sun. Every comet ever photographed shows this. The tail always points away from the sun. Always, except One-Eye Oumuamua shows scattered light extending twice as far toward the sun as away from it. The Hubble image is unambiguous. Enhancement of the data makes it even clearer. There is more stuff sunward than anti-sunward. Avi and Eric Kito published a model suggesting this could happen if the object sheds large ice fragments from its sun-facing side, and those fragments survive longer because they are bigger, creating an extended snowline in the solar direction. The physics works on paper. Ice fragments of specific sizes ejected at specific velocities under specific conditions of solar heating. But those conditions are incredibly narrow. You need preferential ejection from the day side. You need the fragments to be large enough to resist radiation pressure, but small enough to scatter visible light efficiently. You need the evaporation rate to be just right, so the fragments survive long enough to create the observed distribution. It is possible barely. In the same way, it is possible to flip a coin 50 times and get heads every time. The laws of physics do not forbid it, but the probability makes you wonder if the coin is weighted. And this is the pattern. Every anomaly has a natural explanation that works if you're willing to accept that One-Eye Oumuamua is uniquely configured in ways no other comet has ever been. The mass can be explained if it is uncommonly dense. The trajectory can be explained if the statistical fluke happened. The chemistry can be explained if exotic processes are occurring. The polarization can be explained if the dust grain distribution is unlike anything cataloged. Each explanation is plausible in isolation, but they are not in isolation. They stack. 7 anomalies, each requiring its own special pleading, all occurring in the same object. At what point does the simplest explanation to quit acting natural and start acting designed? That's the question scientists are grappling with as the Third Eye Atlas lurks behind the sun. On the data from October 1st, 2025, something zipped within 250 miles of Earth. At that height, astronauts live and work aboard the International Space Station. Commercial satellites orbit in carefully tracked paths. But this object, asteroid 2025 TF, wasn't tracked at all. We discovered it 6 hours after it had already screamed past us at over 13,000 km just above the South Pole. Think about that for a moment. A space rock the size of a small car moving faster than any bullet passed through the exact same airspace where humanity conducts its most advanced operations, and we had no idea it was coming. Meanwhile, on Mars, our rovers found what scientists are calling the clearest sign of ancient life we have ever discovered: leopard spots frozen in time that might prove we were never alone. Congressional hearings just revealed footage of a military missile striking an unidentified object off the coast of Yemen, and the object didn't explode. It kept flying. The sun is entering what physicists call a last gasp phase that could light up our skies with auroras more intense than anything we've seen in decades. Three comets are racing toward us right now, turning green as they approach, and one might become visible to your naked eye within weeks. NASA has furloughed 15,000 employees while racing China to the moon, and a private company is about to launch the most powerful rocket ever built for what might be its final test before a complete redesign. This is not science fiction. This is October 2025. If you're ready to dive deep into what's really happening above our heads right now, hit that like button and subscribe, because we're about to spend the next 2 hours unpacking the most extraordinary space news of our generation. Tell me in the comments where you're listening from, what time it is there, and which of these stories shocks you most. And if you want to help our community grow, share this on X, Facebook, Reddit, or your favorite messenger. Thank you for always having our back. Let's begin with the asteroid that slipped through our defenses. Chapter 1: Close Encounter, the asteroid that snuck up on humanity. We have spent billions of dollars building a planetary defense system. Telescopes scattered across Earth scan the night sky continuously, cataloging every moving object, calculating trajectories, ensuring nothing dangerous approaches without warning. The system works remarkably well for large asteroids, the kind that could wipe out cities or even civilizations. We track those months or years in advance. But on October 1st, 2025, our entire detection network failed to spot something until it was already in our rearview mirror. Asteroid 2025 TF measures somewhere between 1.2 and 2.7 meters in diameter. Not exactly a planet killer, but roughly the size of a compact car. It was traveling at 20.9 kilometers. That's nearly 13,000 km/h, fast enough to cross the United States in less than 4 minutes. At its closest approach, just after midnight UTC on October 1st, this rock passed 419 kilometers above Antarctica. To put that in perspective, the International Space Station orbits at around 420 kilometers. This asteroid flew through the same neighborhood where astronauts sleep. The Catalina Sky Survey in Arizona detected it at 2:35 in the morning Eastern Time on October 1st, using the BOK telescope at Kitt Peak National Observatory. But here's what should keep you awake at night. That detection came at 6 hours and 36 minutes after the asteroid's closest approach. We didn't see it coming. We saw it leaving. Now, asteroid 2025 TF ranks as the second closest asteroid flyby ever recorded. The record holder, asteroid 2020 VT4, passed even closer back in November 2020, coming within 370 kilometers of Earth's surface. But that one we also detected after the fact. There's a pattern here, and it's not a comforting one. The issue isn't incompetence. The astronomers and engineers running these detection systems are among the best in the world. The problem is physics and resources. Small asteroids like 2025 TF are incredibly difficult to spot. They're dark, they're fast, and they don't reflect much sunlight. Our telescope networks are optimized to catch the big ones, the asteroids larger than 150 meters that would cause regional devastation. Those we track religiously, but objects in the 1 to 10 meter range, there are millions of them, and they're nearly invisible until they're practically on top of us. Here's where it gets more interesting. When asteroid 2025 TF was finally spotted, scientists had to work backwards to calculate its orbit. They determined it follows an elongated path around the Sun, with a semi-major axis of 1.62 astronomical units. Its orbit brings it as close as 0.676 astronomical units to the Sun at perihelion and as far as 2.56 astronomical units at aphelion. The orbital period is roughly 2.06 years, and the orbit is tilted about 9.1 relative to the ecliptic plane, the flat disk where most planets orbit. But all of those numbers come with enormous uncertainty. The orbit is what astronomers call poorly constrained with a condition code of 7. That means the calculations are based on just a one-day observation arc, a snapshot so brief that predicting where this asteroid will be in the future is more guesswork than science. Additional observations will be required to refine its trajectory and assess whether it might pose any threat during future encounters with Earth. Think about what this means. An object passed closer to Earth than some of our satellites, and we have only the vaguest idea of where it came from or where it's going next. It could return. It could be on a collision course with Earth decades from now, or it might never come close again. We simply don't know. The uncomfortable truth is that asteroids this size hit Earth more often than most people realize. The Tunguska event in 1908, which flattened 830 square miles of Siberian forest, was likely caused by an object only 30 to 50 meters across. That's larger than 2025 TF, but not by an overwhelming margin. If 2025 TF had been on a collision course, instead of a flyby trajectory, it would have exploded in the atmosphere with the force of several kilotons of TNT. Not enough to end civilization, but certainly enough to devastate a city if it happened to detonate over one. And we wouldn't have known it was coming until it was too late. Scientists are calling this a wake-up call. The near miss has reignited discussions about improving our detection capabilities for smaller near-Earth objects. Because if there's one thing this encounter has made clear, it's that our cosmic neighborhood is far busier and far more dangerous than our current systems can fully monitor. The question isn't whether another asteroid will surprise us. The question is when and whether we'll be lucky enough for it to miss again. But while we're worrying about rocks flying past Earth, something far more profound has been unfolding on the surface of Mars, something that might answer one of humanity's oldest questions. Chapter 2. The Mars Breakthrough. Ancient life smoking gun. For over a year, a rock on Mars has been keeping scientists awake at night. Not because it's unusual in size or composition, but because of what's written on its surface. Patterns that on Earth would be unmistakable signs of life. On September 10, 2025, NASA made an announcement that sent ripples through the scientific community and beyond. The Perseverance rover's discovery of potential biosignatures in a sample called Sapphire Canyon has passed the most rigorous scientific scrutiny imaginable. Peer review and publication in the journal Nature. Acting NASA Administrator Shaw Duffy put it bluntly, this very well could be the clearest sign of life that we've ever found on Mars. Let's rewind to July 24, 2024, when Perseverance drilled into an arrowhead-shaped rock nicknamed Chayava Falls in Mars' Jezero crater. The rover's instruments immediately detected something intriguing. The rock surface was covered in what scientists began calling leopard spots, small circular features with lighter centers surrounded by dark rings. These weren't just pretty patterns. They were chemical signatures that on Earth are often created by microbes consuming organic matter and producing specific minerals as waste products. The spots contain vivianite and greigite, two minerals that form in low-temperature, water-rich environments. Vivianite is a hydrated iron phosphate, often found near decaying organic matter and sediments. Greigite is an iron sulfide that some forms of microbial life produce as a byproduct of their metabolism. Finding these minerals together, collocated with organic carbon, creates what geologists call a compelling potential biosignature. But here's where the story gets even more interesting. Chayava Falls sits in a geological formation called Bright Angel, located along the edges of Neretva Vallis, an ancient river valley that once carried water into Jezero crater more than 3 billion years ago. This valley measures roughly a quarter-mile wide, suggesting sustained, powerful water flow over long periods. The mudstones and layered sediments in Bright Angel tell the story of a dynamic environment where fast-flowing rivers alternated with periods of calm standing water. Exactly the kind of environment where microbial life thrives right here on Earth. The discovery was particularly surprising because Bright Angel represents some of the youngest sedimentary rocks the Perseverance mission has investigated. Earlier hypotheses assumed that signs of ancient life would be confined to older rock formations, remnants of Mars's earliest, most habitable era. But finding these features in relatively younger rocks suggests that Mars might have remained habitable for a longer period than previously thought, or that life managed to persist later into the planet's history than we imagined. Now, before we get carried away, we need to talk about what a potential biosignature actually means. This is not proof of life. It's evidence that requires further investigation. As mission scientist Katie Stack Morgan emphasized, astrobiological claims, particularly those related to the potential discovery of past extraterrestrial life, require extraordinary evidence. The peer review process that led to publication in Nature was deliberately rigorous, with outside scientists spending an entire year scrutinizing the Mars 2020 team's data and analysis. They looked for alternative explanations, non-biological processes that could create the same patterns. And while they found some possibilities, none of them fit the evidence as well as the biological hypothesis. Here's what makes this discovery so powerful. The Perseverance rover used two sophisticated instruments to analyze Chava Falls: SHERLOC, which stands for Scanning Habitable Environments, with Raman and Luminescence for organics and chemicals, detected a strong spectral signature called the Raman, which indicates organic carbon. PIXL, the planetary instrument for X-ray lithochemistry, mapped the distribution of chemical elements across the rock's surface with incredible precision. Together, these instruments revealed that the organic matter and the redox-sensitive minerals weren't just present. They were collocated in the same tiny spots, clustered together in a way that strongly suggests a connection. On Earth, this kind of collocation happens all the time in microbial environments. Bacteria consume organic compounds and release minerals as waste. The minerals precipitate out right where the microbes are living, creating distinctive patterns. The leopard spots on Chava Falls look remarkably similar to features found in ancient terrestrial rocks, where we know microbial activity occurred. But there's a catch, and it's a big one. To truly confirm whether these features have a biological origin, scientists need to bring the Sapphire Canyon sample back to Earth, where it can be analyzed with instruments far more sophisticated than anything we can send to Mars. Laboratories here can perform isotopic analysis, examine the molecular structure of the organic compounds, and conduct experiments that simply aren't possible with a rover's limited toolkit. This is where the political drama enters the story. The Mars Sample Return Mission, a joint effort between NASA and the European Space Agency, was designed to do exactly this: retrieve the samples that Perseverance has been carefully collecting and deliver them to terrestrial labs. But the mission has been plagued by budget overruns and schedule delays. President Trump's proposed budget for 2026 would cancel the current Mars sample return program entirely, zeroing out its funding. During the September press conference announcing the Chava Falls findings, Duffy suggested this wasn't an abandonment of the goal, but a strategic pivot toward finding a cheaper, faster option. Meanwhile, China has announced plans for its own Mars sample return mission, potentially launching as early as 2028. If the United States doesn't bring back Perseverance's samples, China might be the first to return Martian material to Earth, and they might be the ones to definitively answer whether life ever existed on Mars. The geopolitical implications are staggering. For now, the Sapphire Canyon sample sits safely tucked inside a sealed tube on the Martian surface, waiting. It contains what might be the most important scientific discovery in human history: frozen evidence that could rewrite our understanding of life's place in the universe. But while that sample waits, something else has been unfolding much closer to home. Something that's forcing governments to confront questions they'd rather not answer. Chapter 3. UFO Mystery Deepens. Congress reveals shocking footage. On September 9th, 2025, Congressman Eric Burrows from Missouri walked into a House Oversight Committee hearing and played a video that nobody in the public had seen before. The footage, dated October 30th, 2024, shows a bright spherical object moving against a dark background. Then, suddenly, a Hellfire missile enters the frame. The missile strikes the object directly. What happens next defies everything we think we know about how missiles work. The object doesn't explode. It doesn't fragment. It doesn't even seem to slow down. The missile appears to bounce off and continue on its own trajectory, while the orb keeps flying. That's the Hellfire missile smacking into that UFO and just bouncing right off, Burles said, commenting on the video. And it kept going. He paused, then asked the question that's been echoing through defense circles ever since. I'm not going to speculate what it is, but the question is, why are we being blocked from this information consistently? The video. The object was captured by an MQ-9 Reaper drone operating off the coast of Yemen. At the time, the waters near Yemen were an active combat zone, with U.S. Navy ships and aircraft guarding commercial shipping lanes against missiles and drones launched by Houthi militants. American forces were routinely shooting down threats in that region. But this object, whatever it was, didn't act like a drone or a missile, and it sure as hell didn't react to a Hellfire strike the way any known aircraft would. When pressed to verify the video and share details on when and where it was filmed, the Department of Defense stayed silent. A defense official told reporters, "We do not have anything to provide on this." A DoD spokesperson added, "I have nothing for you." The stonewalling only deepened the mystery. But the Yemen video wasn't the only revelation at the hearing. Multiple military veterans testified under oath about their own run-ins with unidentified anomalous phenomena, the government's current term for what used to be called UFOs. Air Force veteran Dylan Bolin described an incident from 2012 when he stepped outside for a cigarette break during an overnight shift at Langley Air Force Base in Virginia. A triangular aircraft hovered above him for several minutes, silent and motionless. Then, according to Bolin, the object shot up to commercial jet altitude and sped out of the area. Bolin reported the incident through official channels. He was interviewed by AARO, the Pentagon's All-Domain Anomaly Resolution Office, in 2023, but instead of being taken seriously, he claims his report was brushed off. Worse, he says he faced workplace retaliation, manipulation of his security clearance, and blacklisting from jobs at federal intelligence agencies. His testimony painted a picture of a system that doesn't just fail to investigate UAP encounters, it actively punishes those who come forward. The hearing wasn't just about individual sightings, it was about transparency, or the lack of it. Representative Annapolina Luna, who chairs the task force, opened the session by saying, "For too long, the issue of unidentified anomalous phenomena, commonly known as UAPs, has been shrouded in secrecy, stigma, and in some cases, outright dismissal. This is about national security, government accountability, and the American people's right to the truth." Here's what makes this moment different from decades of UFO speculation. The witnesses aren't fringe conspiracy theorists. They're military personnel with spotless records, security clearances, and first-hand operational experience. The footage isn't grainy cell phone video from someone's backyard. It's sensor data from advanced military platforms captured during active operations in contested airspace. And the resistance to disclosure isn't coming from shadowy cabals. It's coming from official Pentagon offices that are supposed to be investigating these incidents. AARO has maintained it has no verifiable evidence of extraterrestrial activity or technology. The agency uses what it calls a rigorous scientific framework and data-driven approach to better understand UAP. But critics point out that many of the most compelling cases, including the Yemen incident, seem to get explained away using logic that doesn't quite add up. Take the infamous Go Fast video from 2015, which showed a fast-moving object appearing to zip along above ocean waves off California. Aero analysts eventually determined it was an optical illusion involving a weather balloon, claiming the apparent high speed was due to parallax and the angle from which the Navy FA-18's camera viewed the object. But pilots who witnessed these objects in person, not just on sensors, insist the explanations don't match their experiences. Some analysts have suggested the Yemen orb might also be a balloon, drifting in high-altitude winds and reflecting sunlight. The theory is that it only appeared to be moving rapidly because of parallax motion as the drone's camera tracked it. And the missile, perhaps it simply missed, and the angle of the footage made it look like a direct hit. But former senior intelligence official Lou Elizondo, who testified at the hearing, pushed back hard on that explanation. "We've never seen a Hellfire missile hit a target and bounce off," he said. "When a Hellfire makes a kinetic strike on something solid, there's usually not much left of whatever it is it's hitting. It's very, very destructive." So, what are we left with? Either the US military encountered something with technology far beyond our current capabilities, technology that can withstand a direct missile strike and keep operating, or there's a mundane explanation that officials are refusing to share publicly for reasons we can only guess at. Neither option is particularly comforting, and this isn't an isolated incident. The National UFO Reporting Center logged over 2,000 UAP sightings in just the first 6 months of 2025, a significant increase from previous years. The Pentagon has received more than 750 new reports between May 2023 and June 2024 alone. Whatever is happening in our skies is happening more frequently and more people are paying attention. While governments grapple with objects in the atmosphere they can't explain, something far more predictable but no less dramatic has been unfolding above our heads, driven by the star that makes all life on Earth possible. Chapter 4. Solar Fury, the Sun's Last Gasp. In October 2024, scientists made an announcement that should have dominated headlines, but somehow got lost in the noise of daily life. The Sun has reached solar maximum, the peak of its 11-year activity cycle. For most people, that sounds like dry astronomy, the kind of thing that matters to researchers, but doesn't affect everyday existence. But what's happening to our star right now is anything but academic, and the most intense effects might still be ahead of us. Here's the thing about solar maximum that nobody tells you. The peak of solar activity doesn't mean the end of dramatic events. It means we're entering a phase that could actually produce more geomagnetic storms and more spectacular auroras than the maximum itself. Think of it like a firework that burns brightest, not at ignition, but during its final explosive moments before fading. The Sun is about to give us its last gasp, and that gasp could light up skies across the planet for the next 2 years. Solar physicist Paley from the Norwegian Space Agency put it plainly. It's good news for aurora chasers as peak auroral activity occurs a few years after solar maximum. Thus, we should have several years still with very high aurora activity. Let that sink in for a moment. We're not at the end of the show. We're approaching the grand finale. To understand why, we need to talk about what drives auroras in the first place. During solar maximum, the sun's surface becomes covered with sunspots, regions of intense magnetic activity where the star's magnetic field lines become tangled and stressed. When these field lines snap and reconnect, they release enormous amounts of energy in the form of solar flares and coronal mass ejections. A single CME can hurl billions of tons of plasma into space at speeds exceeding 1,000,000 miles per hour. When that plasma slams into Earth's magnetic field, it triggers geomagnetic storms that funnel charged particles toward the poles, where they collide with atoms in our atmosphere and create the shimmering curtains of light we call auroras. But here's where the story gets more interesting. After solar maximum, the number of explosive flares and CMEs starts to decline. You'd think that would mean fewer auroras, but you'd be wrong. Because during the declining phase of the solar cycle, something else happens. Long-lived coronal holes begin to form. Dark regions in the sun's atmosphere where magnetic field lines open up into space, allowing streams of fast-moving solar wind to escape continuously. These high-speed streams can persist for weeks or even months, battering Earth's magnetic field with sustained pressure that triggers geomagnetic storms just as dramatic as those caused by CMEs. Solar physicist Shah Scoff explained it this way. During the declining phase, we actually have more geomagnetic storms. Maybe the sun's actual eruption activity slows down a bit after you peek through solar max, but because you still have coronal holes forming, and you still have quite a few eruptions. When you add those together, you get more frequent and sometimes more intense auroral displays. We're already seeing this play out. In early October 2025, Earth experienced 5 consecutive days of geomagnetic activity driven by a fast solar wind stream from a coronal hole. Solar wind speeds reached 768 km/s before gradually declining to 608 km/s. Even at those reduced speeds, the wind was strong enough to trigger isolated G1 or minor geomagnetic storm levels. Auroras danced across northern latitudes, visible as far south as New York on some nights. Photographers in Iceland, Norway, Canada, and the northern United States captured stunning images of green, pink, and purple lights rippling across the sky. And this was just a warm-up. A small coronal mass ejection, launched by an M1.5 class solar flare in early October, is expected to arrive around October 8th, potentially bringing another round of disturbances. Scientists are forecasting that the current solar cycle, cycle 25, could maintain high levels of geomagnetic activity well into 2027 or beyond, driven by this combination of lingering eruptions and persistent coronal holes. But there's another factor at play, one that has nothing to do with the sun itself. Earth's orientation during equinox season, which we're still experiencing in early October, makes our planet more susceptible to geomagnetic storms. During equinoxes, the angle of Earth's magnetic field relative to the incoming solar wind C creates conditions that let more particles slip through our defenses and spark fiercer auroral shows. It's like swinging open a door that's normally half shut. The real-world fallout from all this solar frenzy stretches way beyond the dazzling displays. Geomagnetic storms can scramble radio signals, mess with GPS, drag satellite orbits lower, and in bad cases, even knock out power grids. Take the massive geomagnetic storm of March 1989, sparked by a monster CME. The whole province of Quebec went dark for 9 hours. Transformers fried from the heat, breakers flipped, and millions sat in the pitch black. That one hit G5, or extreme, on the geomagnetic storm scale. The storms hitting now have mostly clocked in at G1 to G3, tame by comparison, but still tough enough to give satellite crews and polar route pilots real migraines. Scientists track geomagnetic buzz with the KP index, a 0 to 9 scale. A KP of 5 or higher means storm time. In the first week of October 2025, the KP bounced between 3 and 5, with quick jumps into storm zone. Forecasters say it'll keep up this vibe, lots of unsettled to active spells, dotted with the odd big blow, through the months ahead. For folks not wrangling satellites or power plants, the big perk from this solar rampage is pure eye candy. Auroras rank among Earth's wildest natural wonders, and the next 2 years could deliver prime viewing in decades. If you're up north or south of 50-degree latitude, expect steady shots at the lights, but even mid-latitude spots down to 40-degree or so might snag peaks during the heavy hitters. The sun's final hurrah is shaping up as a sky show for the history books. But while the sun's torching our heavens with flames, other spacefarers are closing in from the void, packing their own kind of dazzle. Chapter 5. Comet Chaos. 3 green visitors light up October skies. Something odd's brewing in October 2025. Scan the right patch of sky on the right evening from the right spot, and you could spot not 1, not 2, but 3 comets all at once. All green-tinged, all fresh finds from this year. And one might blaze bright enough for naked eye viewing. A real treat in an age when comets mostly tease and fade. Leading the pack is Comet C2025A6, aka Comet Lemon, named for the Mount Lemmon Observatory in Arizona, where it popped up on January 3, 2025. Back then it glowed at magnitude 21.5, so dim pros figured it for an asteroid at first. Only later checks showed the fuzzy coma and stubby tail that screamed comet. For months, Lemon stayed a pros-only secret, logged by experts but off the public radar. First guesses pegged its peak at magnitude 9, around perihelion in early November. Decent for backyard scopes, but no unaided eyes. Then, it threw a curveball. Mid-August, post-solar conjunction when it had vanished in the sun's blaze, spotters saw it way brighter than expected. By August 19th, magnitude 11. A stubby, spiky tail emerged, and the glow-up kept rolling. Late September, Comet Lemon hit 8 to 9, a snap for binos and small scopes. Astrophotographers snapped killer shots. Not just the glowing core and hazy coma, but a long ion tail whipping away from the sun, twisted with curls and clumps from clashing with solar wind. On September 30th, it had climbed to magnitude 6.6, with an ion tail spanning about 3 degrees and a dust tail starting to show. Fresh data rolling in daily tweaks the outlook. Comet Lemon should hit magnitude 4, maybe even 3, at its Earth closest on October 21st, just 56 million miles out. That's teetering on naked-eye turf. From pitch-black sites away from urban glow, you might pick it out as a hazy star, and unlike comets that flare too near the sun for safe looks, Lemon will hang in the evening west, 42 degrees from the sun, about an hour post-sunset. It'll keep brightening past closest approach, cruising to perihelion, sun's nearest kiss, on November 8th. Prime time hits around Halloween into early November as Lemon slices through the constellation of Fucus. For Northern Hemisphere skywatchers, this is a one and only shot. Comet Lemon traces an extremely elongated orbit and may not return for 1,350 years, if it returns at all. But Lemon isn't alone. Comet C2025 R2, SWAN, was discovered just weeks ago, literally one day before reaching its closest point to the sun. We didn't see it sooner because the sun's glare hid it from ground-based telescopes. It was actually spotted by sharp-eyed amateur astronomers Vladimir Bajuk and Michael Mattei in images taken by the SWAN instrument aboard NASA's Solar and Heliospheric Observatory, a space-based telescope designed to study the sun, hence the name SWAN. This comet won't get much brighter as it's now moving away from the sun, but it will get easier to see as it puts more distance between itself and the sun's glare from our perspective. On October 20th, it will make its closest approach to Earth at a distance of 24 million miles. Spectacular photographs have already captured its tail, stretching past the star Spica. This weekend, it will pass within a degree of Mars, creating a beautiful photo opportunity for astrophotographers who can frame both objects together. The third member of this cosmic trio is Comet C2025 K18, Atlas, named after the asteroid terrestrial impact Last Alert System, a survey designed to find near-Earth asteroids, but clever enough to spot comets too. K18 is fainter than the other two, but it's getting brighter as it approaches the sun. It will be best visible before dawn in the coming weeks for patient observers with binoculars or small telescopes. Why are all three comets green? The color comes from diatomic carbon molecules made of two carbon atoms bonded together, which absorb sunlight and re-emit it at a wavelength that appears green to human eyes. As comets approach the sun, solar radiation breaks apart larger organic molecules in their icy cores, releasing diatomic carbon into the coma. The closer they get, the more carbon gets released, and the greener they glow. Interestingly, there's a fourth green comet currently visible, though it's much harder to spot. The interstellar visitor 2I Borisov, only the second comet from beyond our solar system ever detected, recently abandoned its crimson hue and turned emerald as it interacts with the sun's radiation in ways we're still trying to understand. But that's a story we'll return to shortly. Comet Lemon has already exceeded all expectations, and there's genuine excitement among astronomers about how bright it might become. Nick James, director of the Comet section of the British Astronomical Association, told spaceweather.com, "This comet is developing very nicely, and it is already an impressive object, well placed for observation in the morning sky. It is definitely worth getting up for. The unpredictability is part of what makes comets so captivating. They're not like planets or stars, following predictable paths and maintaining steady brightness. Comets are wild, erratic, sometimes disappointing, occasionally spectacular. They can brighten in sudden outbursts, fragment without warning, or fizzle into obscurity just when they were supposed to put on a show. Predicting a comet's behavior is like predicting the weather 6 months in advance. You can make educated guesses based on physics and past behavior, but nature always reserves the right to surprise you. And surprises are exactly what we're getting in October 2025. Three green comets racing through our skies at once, one potentially visible to the naked eye, the sun blazing with activity, auroras dancing at mid-latitudes, asteroids sneaking past our defenses, and on Mars, a rock covered in patterns that might be fossils of ancient life. But while all this cosmic drama unfolds naturally, one company is preparing to launch the most powerful rocket ever built, a machine that could either revolutionize space travel or become another footnote in the long history of ambitious failures. Chapter 6: Starship's Final Act. SpaceX's Make or Break Moment. October 13th, 2025. Mark that date. If all goes according to plan, and with SpaceX, that's never a guarantee, the world will witness the 11th test flight of Starship, the tallest and most powerful rocket ever built. But this isn't just another launch. Flight 11 will be the last time we see Starship version 2 fly. Everything after this will be bigger, more powerful, and theoretically more reliable. The question is whether version 2 can go out on a high note, or whether it will add one more explosion to a year that's already seen far too many. Let's talk about the elephant in the room. 2025 has not been kind to Starship. The year started with back-to-back explosive failures that shook confidence in the entire program. Flight 7 in January saw the upper stage, known as SHIP, experience a catastrophic breakup during its initial burn. 4 of its 6 engines shut down prematurely, causing loss of attitude control and total loss of telemetry. The vehicle's breakup was visible from Florida, Jamaica, and the Turks and Caicos Islands. Flight 8 in March. Flight 8 looked like a win at the start. The Super Heavy booster got snagged by the launch tower's mechanical arms, a real jaw-dropper. But Ship 34 dealt with 4 engine shutdowns, mid-burn, lost control, and came apart 9.5 minutes after liftoff. Then, Flight 9 rolled around in May, bringing the program's first reused Super Heavy booster, yet another big step. But once more, the upper stage couldn't finish the job. 3 flops in a row, 3 ships gone, 3 probes, 3 waves of tweaks and vows that the next one would turn out better. Flight 10 in August finally snapped the skid. It all clicked. The booster hit the splashdown right on cue. The ship nailed its suborbital path, plunged back through the atmosphere with the heat shield holding strong, and pulled off a controlled ditching in the Indian Ocean. It even popped out Starlink satellites mid-flight, a key capabilities showcase. For the first time in months, SpaceX and its backers could breathe easy. Now Flight 11 is up, set for 6:15 p.m. Central Time on October 13th, blasting off from Starbase in South Texas. The mission outline echoes Flight 10, but with a few big shifts that amp up the boldness and the stakes. The booster in play, tagged B-15, already flew on Flight 8 way back in March. It got caught by the tower that time, so it's battle-tested gear. This go-round, it's packing 24 flight-proven Raptor engines, meaning both the booster and nearly all its power plants have endured the grind of launch and touchdown. But here's the kicker. No tower catch attempt this time. B-15 will run a novel landing burn setup that SpaceX eyes for the next-gen Super Heavy version 3. The booster fires up 13 engines to kick off the landing burn, then shifts to a fresh pattern with 5 engines humming through the divert phase. Before, that segment ran just 3. This 5-engine tweak builds in extra backup against random shutdowns, an issue that's dogged multiple flights. At last, the booster drops to its 3 central engines to wrap the landing burn. hovering steady over the Gulf of Mexico before cutting out and splashing down. SpaceX dubs it a stress test. They're aiming to gauge live vehicle behavior as engines cut and reignite across the burn stages. If it pans out, it greenlights the version 3 strategy. If it bombs, hey, at least it flops over water, not right by the pad. Upper Stage Ship 38 has its own bold lineup. It'll release 8 Starlink simulators, stand-ins roughly the size and weight of the next-gen Starlink birds SpaceX aims to haul to orbit commercially. These dummies won't function like real sats. They're riding the same suborbital loop as Starship and will torch up on re-entry, but the drop tests the gear and steps for actual ops. Ship 38 will also try relighting one of its Raptors in space, proving it can pull off moves beyond basic drifting. That skill's vital for downstream trips to the Moon, Mars, or whatever spots demand spot-on orbit tweaks. Next up, the heat shield trial, and that's where they crank the deliberate danger. Engineers yanked tiles from spots all over Ship 38 to hammer test soft spots vehicle-wide. Some gaps lack any backup ablative underlayer. If re-entry plasma sneaks through those holes, it might torch the frame and spark a total wipeout. But SpaceX has to pinpoint the frailties and gauge how much heat the ship can soak before cracking. The sole path to that intel is shoving it till it snaps. If Ship 38 makes it through re-entry, it'll execute a dynamic bank flip on the way down, vetting subsonic steering code that's key for later returns to the pad. Then, a landing burn and splash in the Indian Ocean, fingers crossed in one chunk. All this feeds into version 3. The Starship build SpaceX figures will at last get the stack fully flyable. Version 3 craft will stretch bigger, pack more fuel, and swallow heftier payloads. The boosters will crank extra engines for bigger shove. Above all, the blueprint folds in takeaways from 10 prior test jaunts and endless flops, blasts, and near misses. But it all hangs if Flight 11 veers off course. If Ship 38 shreds in the heat shield grind, naysayers will wave it as proof Starship's broken at the core. If the booster's fresh landing burns setup tanks, it stirs doubts on whether the whole tack even works. And if anything goes wrong in a spectacular public way, it could impact SpaceX's relationship with NASA, which is counting on Starship to land astronauts on the Moon during the Artemis 3 mission in 2027. The stakes couldn't be higher. Starship isn't just a rocket. It's the centerpiece of SpaceX's vision for the future of spaceflight. It's supposed to make access to orbit cheap and routine. It's supposed to enable Mars colonization. It's supposed to revolutionize satellite deployment, refuel itself in orbit, and eventually carry humans beyond Earth on journeys that currently exist only in science fiction. But first, it has to stop exploding. Flight 11 is SpaceX's chance to prove that version 2 can end its run on a successful note, building momentum toward the version 3 era. The launch window opens on October 13th. Millions will be watching, and in the silence before ignition, everyone will be thinking the same thing. Please don't blow up. While SpaceX races to perfect its giant rocket, another nation is executing a mission that's already billions of miles from Earth, heading toward a target that might hold secrets about our own moon's violent past. Chapter 7. China's Moon Mystery. Tianwen-2's daring mission. On May 28, 2025, at 1:31 a.m. local time in China, a Long March 3B rocket climbed into the night sky above Xichang Satellite Launch Center in Sichuan Province. Most of the world barely noticed, but what that rocket carried into space might answer one of the strangest mysteries in our cosmic neighborhood. Is there a piece of the Moon floating in orbit around Earth, pretending to be an asteroid? The spacecraft is called Tianwen-2, the second mission in China's planetary exploration program. Tianwen-1 went to Mars, delivering an orbiter and a rover that are still operating today. Tianwen-3 will attempt to bring samples back from Mars, potentially beating NASA's troubled Mars sample return program. Tianwen-4 will visit Jupiter and its moons in a single mission. But Tianwen-2 has a target that's much closer and far more mysterious. An object called Kamo-Oa-Lewa, also known as Asteroid 2016 HO3. Kamo-Oa-Lewa is what astronomers call a quasi-satellite, a near-Earth object that appears to orbit our planet even though it's actually orbiting the Sun. Its orbit is synchronized with Earth's in such a way that from our perspective, it looks like it's dancing around us, never straying too far, never getting pulled away. The asteroid measures between 40 and 100 meters across, roughly the size of a Ferris wheel. It completes one orbit around the Sun every 365 days, almost exactly matching Earth's own year. And it's been doing this peculiar dance for at least a century, possibly much longer. But here's what makes Kamo-Oa-Lewa truly strange. Its spectrum, the way it reflects sunlight, closely resembles weathered lunar rocks. In 2021, astronomer Ben Sharkey led a study suggesting that this asteroid might actually be a massive boulder ejected from the Moon by an ancient impact. The name Kamo-Oa-Lewa comes from a Hawaiian creation chant that alludes to an offspring traveling on its own, a poetic description of a moon fragment wandering through space while staying near its parent. If this theory is correct, Kamo-Oa-Lewa could tell us about the Moon's bombardment history, the size and energy of impacts that have shaped the lunar surface, and even provide pristine samples of lunar material that haven't been contaminated by Earth's environment. But there's another possibility. Kamo-Oa-Lewa might instead be a main belt asteroid that somehow migrated into a semi-captured orbit near Earth through gravitational interactions we don't fully understand. That would be equally fascinating, revealing migration pathways through the solar system that current models don't predict. The only way to know for sure is to go there and collect samples. That's exactly what Tianwen-2 is designed to do. On June 6th, just over a week after launch, the China National Space Administration released the mission's first update. The spacecraft was operating normally and had traveled more than 3 million kilometers from Earth. A photo showed one of Tianwen-2's solar arrays, photographed by an engineering camera, floating against the black of space. The image was simple, almost mundane, but it confirmed the spacecraft was alive and healthy. Tianwen-2 is now on a year-long journey to Kamo-Oa-Lewa. When it arrives in 2026, it will spend another year orbiting the tiny asteroid, studying it from close range, mapping its shape and surface, measuring its mass and composition. This will be extraordinarily difficult. Kamo-Oa-Lewa is the smallest asteroid ever targeted by a space mission, and it rotates once every 28 minutes, making it the fastest rotator ever visited by a spacecraft. Landing on something that's small and spinning that fast is like trying to grab a merry-go-round while blindfolded. China plans to use 3 different sampling techniques. The first is a hovering approach, where the lander matches rotation with onto the asteroid while collecting material. The second is a touch-and-go maneuver, similar to what NASA's OSIRIS-REx and Japan's Hayabusa 2 missions used successfully. The spacecraft briefly makes contact with the surface, grabs a sample, and immediately lifts off. The third, most ambitious approach involves using drills on the lander's legs to anchor the spacecraft to the asteroid's surface, allowing for more controlled, longer duration sampling. The goal is to collect at least 100 g of material, a little more than 3 Oz. That might not sound like much, but when you're sampling an asteroid 40 million miles from Earth, with a robotic spacecraft operating autonomously because of communication delays, every gram is precious. Once the samples are secured, Tianwen-2 will begin the journey home. In 2028, about 2.5 years after launch, it will approach Earth and release a re-entry capsule containing the asteroid samples. That capsule will have to survive entry speeds of 12.1 km/s, faster than anything returning from the Moon, generating temperatures and pressures that will push Chinese heat shield technology to its limits. But here's where the mission gets even more ambitious. After releasing the sample capsule, Tianwen-2 won't retire. Instead, it will use Earth for a gravitational slingshot, flinging itself onto a transfer orbit toward a completely different target. Main Belt Comet 311P Pan-STARRS. The journey will take about 7 years. If everything works, Tianwen-2 will arrive at the comet in the mid-2030s, orbit it, and conduct remote sensing studies of this strange hybrid object that has characteristics of both asteroids and comets. The entire mission is designed to last a decade. One spacecraft, two completely different targets, sample return from a quasi-satellite, then a rendezvous with a main belt comet. It's audacious, complex, and if successful, will demonstrate capabilities that only a handful of nations possess. More importantly, it's a direct challenge to American space dominance. While NASA struggles with budget cuts, workforce reductions, and political interference, China is executing a carefully planned, well-funded program of robotic exploration that's advancing steadily toward ever more ambitious goals. Tianwen-2 launched on schedule. It's operating normally, and in 2028, it might deliver the first samples from Kamo-O'Alewa to laboratories on Earth. If those samples confirm the asteroid is a lunar fragment, China will have answered a major scientific question and demonstrated its technical prowess in deep space operations. If NASA's Mars Sample Return Program continues to languish while China brings rocks back from both an asteroid and eventually Mars, the symbolic implications will be impossible to ignore. The space race isn't over. It's just entering a new phase, one where the finish line keeps moving and the competitors are running very different races. China is playing the long game, methodically building capabilities, launching missions, collecting data, and proving that patient, sustained investment in space exploration pays dividends. Right now, Tianwen-2 is millions of kilometers away and getting farther every day, riding on sunlight and ion thrust toward a target most people have never heard of. But when it arrives, when it collects its samples, when those samples come home, the world will pay attention. Because at that moment, another nation will have done something only the United States, Japan, and now China can claim: successfully returned material from beyond the moon. But while China steadily advances its space program with clear goals and stable funding, the American Space Agency, that once put humans on the moon, is facing an existential crisis that threatens to undo decades of achievement and erase missions that have already launched. Chapter 8: NASA, in Crisis, Shutdown, Layoffs, and the Fight for Science. At 12:01 a.m. on October 1st, 2025, the United States federal government officially shut down. Within hours, 15,000 NASA employees received furlough notices and were sent home. Labs went quiet. Offices closed. Ongoing research ground to a halt. For most of the agency, work stopped entirely. But not for everyone. A small fraction of NASA's workforce, just over 3,000 people, were classified as essential and required to keep working. They won't receive paychecks during the shutdown. They'll log their hours and hope for back pay when the government reopens, but they have to show up because the work they do literally keeps spacecraft alive. Mission control operations for the International Space Station continued uninterrupted. Ground controllers still monitor life support systems, prepare and validate commands, and respond to emergencies. About 1,000 commands per day flow from Earth to the ISS to maintain operations and keep the crew safe. If those controllers were furloughed, astronauts' lives would be at risk, so they work unpaid, while Congress argues over budgets. The other major exception to the shutdown is the Artemis program, NASA's effort to return humans to the moon. Acting Administrator Shaw Duffy made the agency's priorities crystal clear in a social media post before the shutdown. China is not going to the moon with good intentions. The implication was obvious. Beating China to the lunar surface is considered a national security imperative, important enough to exempt thousands of workers and contractors from furlough. This includes employees working on Artemis II, the crewed test flight around the moon, scheduled for as soon as February 2026, and Artemis III, the actual moon landing mission planned for mid-2027. It also includes contractors at SpaceX and Blue Origin who are developing lunar landers and other hardware for the program. Those contractors were told to keep working through the shutdown, logging their time without immediate payment because Artemis cannot be allowed to slip further behind schedule. But here's what the shutdown doesn't tell you. The crisis at NASA began long before October 1st. Earlier in 2025, the Office of Management and Budget and Acting NASA administrators issued directives to slash the agency's workforce by more than 4,000 employees. From the end of September through January 9, 2026, thousands of longtime NASA employees are leaving through deferred resignation offers. These aren't furloughs. These are permanent departures. Over 20% of NASA's workforce gone. And it's not just numbers. These resignations have included top-tier talent, engineers who worked on Artemis systems, scientists who manage planetary missions, experts in fields like power systems, propulsion, and life support. One NASA employee at Johnson Space Center in Houston, speaking anonymously, said the agency has lost at least one of its foremost experts in power systems, a critical loss for developing the nuclear reactor needed to generate power on the moon. The exodus is being driven by budget uncertainty and political pressure. President Trump's proposed budget for fiscal year 2026 requests the lowest NASA funding since 1961, adjusted for inflation. That was the year Alan Shepard became the first American in space. The budget proposal includes a devastating 47% cut to NASA's science programs. If enacted, it would cancel 41 missions, including spacecraft already launched and making discoveries. Let that sink in for a moment. 41 missions canceled, not missions that are still being planned or developed, missions that are already flying, telescopes already observing distant galaxies, probes already exploring other planets, satellites already monitoring Earth's climate. The proposal would literally turn off spacecraft that have been journeying through the solar system for decades, wasting billions of taxpayer dollars and erasing knowledge that can never be recovered. The list of threatened missions reads like a greatest hits of human space exploration. The Nancy Grace Roman Space Telescope, a flagship observatory designed to discover hundreds of thousands of exoplanets and survey over 1 billion galaxies, would be canceled despite being nearly complete. OSIRIS-APEX, currently on its way to study asteroid Apophis during its close flyby of Earth in 2029, would be shut down mid-flight. The Mars Sample Return mission, despite already having samples sitting on Mars waiting to come home, would be abandoned, potentially allowing China to beat America in returning Martian material to Earth. Even missions that have already proven their worth aren't safe. The Chandra X-ray Observatory, which has been observing the high-energy universe since 1999 and making discoveries that have reshaped astrophysics, is on the chopping block. The Hubble Space Telescope, perhaps the most famous scientific instrument ever built, could see its mission support reduced or eliminated. The proposed cuts don't just affect space exploration. Earth science missions that monitor climate change, track deforestation, measure sea level rise, and provide data essential for weather forecasting and disaster response are also targeted. Planetary defense programs designed to find and track asteroids that could threaten Earth would see reduced funding. Ironic, given the recent surprise flyby of Asteroid 2025 TF. Whistleblowers within NASA have spoken out, noting that imposing a budget that hasn't been approved by Congress is illegal and defies constitutional principles. NASA's legal office should know better. One said they should know that what this administration is doing is breaking NASA procedures, NASA regulations, and not following the will of Congress. But the violations continue, often hidden from public view. The human cost of these cuts extends beyond NASA employees. Universities across the country rely on NASA grants to fund research and pay graduate students. When grant payments halt during shutdowns or budget cuts, entire research programs can collapse. Professors find themselves unable to pay their teams. Students lose funding mid-decay. Decades of hard-won expertise and deep institutional know-how just vanish as folks get pushed out of the field for good. UV astrophysicist Stephen McCandless from Johns Hopkins University, who heads up NASA's sounding rocket projects, says the upheaval has totally shifted how they think about funding availability. He's had to beg his university for emergency cash just to make it through the next launch, and he's one of the fortunate ones working at a big research powerhouse with the resources to soften the hit. Smaller outfits at poorer schools have zero backup. Meanwhile, international partners are looking on with growing unease. NASA's teamwork with the European Space Agency on ventures like Mars, Sample Return, and the Artemis program comes with ironclad commitments and split expenses. When NASA upends plans or axes missions on its own, it puts real stress on ties that took years to forge and chips away at America's standing as a dependable ally. Maybe the worst hit is the erosion of public confidence and scientific drive. Space exploration is a marathon. Missions demand years or decades to design, construct, launch, and carry out. You can't hit pause on a planetary probe halfway through its journey and pick it back up later. You can't push back a Jupiter mission by a year and count on the planets to hang around. The rules of orbital mechanics couldn't care less about fiscal years or election year politics. When that steady flow gets interrupted, when programs keep getting scrapped and rebooted over and over, when skilled pros bail and no one steps in to fill their shoes, the harm piles up. Every binned mission means a breakthrough that never happens. Every departing expert wipes out decades of hands-on wisdom. Every halt forces a grueling rebuild of momentum from the ground up. And yet, hope lingers. The space crowd is pushing back hard. Rallies have popped up outside NASA headquarters in Washington, D.C., with staffers and backers calling for full budgets and a stop to the slashing. Lawmakers from both sides, especially those from areas hosting big NASA sites, are digging in against the White House's ideas. The House and Senate have rolled out spending bills that top the president's ask. But as of early October, nothing's locked in. The big question is if this pushback will hold, if Congress will flex its constitutional muscle on federal dollars and shoot down the cuts that'd kneecap U.S. dominance in space, if everyday folks will press their reps to safeguard the outfit that delivered the moon landings, the Mars rovers, the Hubble and Webb telescopes, and generations of breakthroughs that broadened what we know and fired up the world. Because right now, NASA faces a fork in the road. One route keeps the exploration going, the science advancing, and America out front in space. The other spells a slow fade, scrapped flights, drained talent, and sitting on the bench while others charge past. The call isn't coming from scientists or engineers. It's coming from polls and paper pushers, plenty of whom will never feel the fallout of their choices. While the ones who've poured their lives into unlocking the universe watch it all get torn apart bit by bit. This is October 2025. Asteroids zip by unnoticed. Hints of life stay iced over on Mars. UFOs show up in military clips with zero solid answers. The sun powers through its last burst of activity. Comets barrel in from the void. China runs bold missions with sharp focus and rock-solid backing. A private outfit crafts the mightiest rocket ever, while the government body that once landed people on another planet fights just to stay afloat. The universe pays no mind to our funding fights or partisan spats. It keeps spinning its timeless routine, unbothered by whether we bother to observe, to probe, to venture out, or to turn our backs and act like the stars hold no sway. But they do. Every find we uncover, every puzzle we crack, every enigma we decode, builds up our collective grasp of reality and nudges us to remember we're threads in a tapestry way bigger than our own lives. And right now, we're risking losing sight of that fact precisely when it counts the most.